Hello, welcome to exercise 5F, inverse relations and functions. Looks really hard. The textbook makes it look much worse than it is. It's really not that hard. Two big things, well, three big things. The graph of the inverse relation, you get the graph of the inverse by sketching along that. I'll show you what that means later. The domain of the inverse is the range, like you swap the domain and range. Again, I'll show you what that means later. Key bit, equation of the inverse relation, you swap x and y. I'll show you what that means. Okay. So with inverses, it's kind of better to dive into questions before getting confused with the theory. So let's have a look at example 17. For 17a, they want us to write down the inverse relation. So at the moment, we've got x minus 3 squared plus y squared equals 1. And that's a circle with center. It's moved right 3, but up nothing. And radius, square root of 1 is 1. If we want to find the inverse, we literally just write it. We swapped x's and y's. So instead of x take 3, we've got y take 3 squared plus x squared equals 1. And this is now, we would normally write it with the x thing first. So this is a circle, center, 0, minus 3, radius, still 1. And now we want to sketch them both. I'm not going to do an amazing job. So our first one is that circle. Technically, we've reflected along the line y equals x. So we now go from this circle we go up that way when we reflect it. Let me get rid of that. And it becomes that circle, but pretend I'd done a better job of it. And write down the domain and range of both functions. So this one, the domain, well, if its center is 3 and it's going left and right 1 each, it's going to be between 2 and 4. And the range, we're starting off at 0, we're going up and down 1, so that should not have been y, that should not have been x. So -1 to +1. And then for our inverse, our domain, well, if you look at it, you can see that the domain is between -1 and 1, because it's the x values. It started off at x equals 0 and it goes left and right 1. And the range, well, we go from 2 up to 4. And see how the domain and range have literally just swapped between our inverse and our basic one. Neither are functions. You can't draw, remember vertical line test? They both fail. So neither are functions. All right, this one, example 19, we've just got a normal straight line. I'm just going to start off by sketching this straight line. It has not asked you to sketch it. You do not need to sketch it. But it's a straight line, 2x take 3, so we go through -3, and for every 1 we go across, we go up 2, so which means it's got a gradient of 2, it's going to be going like that. And they only want where x is greater than or equal to 1. So, that's why we had that. Oh, greater than 1. So I do a open dot here, okay? Because it doesn't actually touch that one. Write down the equation and the condition of the inverse relation. So if I have y equals 2x minus 3, where x is greater than 1, then the inverse, I've got x equals 2y minus 3, y greater than 1. So I'm literally just swapping the x and y's. And now I've got to rearrange it to get y equals. So I've got x plus 3 equals 2y, which means y equals x plus 3 over 2, which is the same as half x plus 3 on 2. Again, the whole time, the restriction on y is that y is greater than 1. And if I want to sketch this one now, I'll do it in purple. I'm going through here, and for every rise over 1, every 2 I go across, I go up 1. So that one's going to look like this. And if I make the condition y is greater than 1, so I'm starting off here and going that way. Which, if I had started off with a mirrored, with my line along y equals x, you can see that they're kind of mirrored along that. Well, if I'd drawn them better, they would have been. So that's good. Yeah, you didn't actually have to draw. I just wanted to show you. So these questions in this chapter, they're not hard. I just don't want you to overthink it.